4 billion miles from the sun, there's a small frozen world that appears to be doing something no other atmosphere in the solar system does. It is cooling itself down on purpose, using nothing but a thin layer of haze in its own sky. Scientists only confirmed this in 2025, and it forces a complete rethink of what a dead world at the edge of the solar system is actually capable of. To appreciate how strange this is, you have to go back to July 2015 when NASA's New Horizons spacecraft became the only human-made object ever to fly past Pluto up close. After a 9.5-year journey, it swept by at over 30,000 miles an hour, with exactly one shot to gather everything it could before continuing on into the dark. What it captured rewrote the textbook entry for Pluto completely. A massive, pale, heart-shaped plain of nitrogen ice, water ice mountains rising over 10,000 feet into a hazy sky, and layer upon layer of blue haze extending hundreds of miles above the surface, glowing faintly even when backlit by sunlight. Pluto did not look like a dead chunk of ice. It looked like a world still quietly doing something. But New Horizons only got that one look. It flew on, deeper into the Kuiper Belt, never to return, leaving scientists with spectacular photographs and no real way to keep studying what was actually happening in that haze. To go further, researchers needed something that didn't need to fly there at all. They needed to read Pluto's chemistry directly from millions of miles away. That's exactly what the James Webb Space Telescope was eventually built to do. Webb doesn't take a snapshot as it flies past. It breaks light apart into its individual wavelengths, extracting the precise chemical and thermal fingerprint of whatever it's staring at. The challenge was that Pluto and its largest moon, Charon, sit so close together in Webb's view that separating their heat signatures had defeated every earlier telescope that tried. Webb's larger mirror and far more sensitive infrared instruments finally solved that problem, isolating Pluto's own faint thermal signal for the first time in 2022. What came back wasn't just a better picture, it was closer to a full diagnosis, and the first major result confirmed something a planetary scientist named Xi Zhang had proposed back in 2017, an idea most of his colleagues considered backwards at the time. On Saturn's moon, Titan, atmospheric haze traps heat and warms the surface below it. Zhang argued Pluto's haze does the opposite, absorbing sunlight during the day and radiating that energy straight back out into space as infrared heat, faster than Pluto's paper-thin atmosphere could ever hold onto it. Not a blanket, a radiator, actively bleeding away heat from a world that had almost none to spare in the first place. Nobody could test that idea until Webb's mid-infrared instrument became sensitive enough to cleanly separate Pluto's signal from Charon's. In June 2025, a research team led by astronomer Tanguy Bertrand at the Paris Observatory published results in Nature Astronomy, confirming almost exactly what Zhang had predicted 8 years earlier. Pluto's upper atmosphere really is being actively cooled by the haze particles suspended inside it, running roughly 30 degrees Fahrenheit colder than earlier models expected. Researchers are now calling this a genuinely new kind of climate, one that behaves unlike any other atmosphere we've studied anywhere else in the solar system, and possibly a clue to what similar hazy worlds like Neptune's moon Triton are doing, or even what Earth's own sky may have looked like billions of years before oxygen ever filled it. There's a second effect tied to that same haze that's just as strange once you sit with it. Even the faint trickle of sunlight reaching Pluto is enough to break apart methane molecules high in its atmosphere. Those fragments don't just disappear, they recombine into heavier compounds called tholins, reddish-brown particles that drift down and settle onto the surface below, a process New Horizons caught early traces of, and that Webb has continued to refine. Tholins belong to the same broad family of organic molecules some scientists believe once rained down onto early Earth, potentially supplying raw material for the chemistry that eventually led to life here. On Pluto, that same slow snowfall of biological building blocks has apparently been falling for roughly 4 billion years, onto a surface simply too frozen for any of it to ever spark into something alive. To understand exactly how frozen, consider the numbers. Sunlight reaching Pluto is about 1,000 times fainter than sunlight reaching Earth, meaning even high noon, there resembles a deep twilight here. Surface temperatures hover between roughly negative 387 and negative 369 degrees Fahrenheit, more than 250 degrees colder than the coldest temperature ever recorded anywhere on Earth. At that temperature, nitrogen, the same gas making up most of the air in your lungs right now, freezes completely solid. The third finding is the one that tends to genuinely unsettle people once they hear it explained. Pluto has been slowly leaking its atmosphere into space for billions of years, methane and other light molecules drifting upward and slipping past its weak gravity. For a long time, nobody knew exactly where all that escaping material actually went. It turns out something has been catching it. Charon. Most of Charon's surface is unremarkable, ancient water ice except at its poles, stained a deep, unmistakable reddish-brown, darker than anything else on the moon. Because of how Charon is tilted, its polar regions spend decades at a time in complete darkness, turning each pole into an extremely effective cold trap. Escaping methane drifts in, freezes solid for lack of any warmth, and accumulates for years. When sunlight finally returns, it doesn't melt that ice away. Instead, ultraviolet radiation and cosmic rays tear the frozen molecules apart and reassemble them into heavier, permanently dark compounds. Two worlds locked together in a slow, silent exchange of atmosphere and color that has apparently been running since long before either one had a name. Charon had one more surprise waiting. In October 2024, a team led by researcher Sylvia Protopapa at the Southwest Research Institute used Webb data to confirm both carbon dioxide and hydrogen peroxide, frozen directly onto Charon's surface, a chemical combination never confirmed there before, adding yet another layer of complexity to a moon that keeps turning out to be far stranger than its plain icy appearance suggests. Try to picture actually standing on Pluto for a moment. The sun would appear only as an intensely bright point of light, smaller than a pinhead held at arm's length, giving off no real warmth at all, faint enough to look at directly without discomfort. The sky would sit in a permanent grayish-blue gloom, never fully day, never fully night. The ground wouldn't behave like ice on Earth. At nearly 400 degrees below zero, water ice stops being slippery and behaves more like solid rock, hard enough to ring almost like metal if struck. And overhead, Charon would hang motionless in the exact same spot in the sky forever, the two worlds locked so tightly in mutual orbit around a shared point in space that each one always shows the same face to the other. The surface itself hides still more mysteries. In a region called Tartarus Dorsa, New Horizons photographed towering blades of frozen methane ice, some over 1,500 feet tall, arranged in long parallel ridges, a vastly scaled-up version of a formation seen occasionally in Earth's high-altitude deserts where similar but much smaller blades rarely grow taller than a person. A 2025 reanalysis of the original flyby data suggests these ice blades may wrap around as much as 60% of Pluto's equator, an entire ring of jagged frozen terrain circling the dwarf planet. South of Pluto's famous heart-shaped plain rise two enormous isolated peaks that researchers still can't fully explain, one roughly 13,000 feet tall, the other close to 20,000, each with a deep depression at its summit and lumpy flanks resembling cool lava flows, despite there being no molten rock anywhere on Pluto. If these are what they appear to be, they're cryovolcanoes, structures that once erupted, not with melted stone, but with a thick slurry of water, ammonia, and methane forced upward from somewhere deep beneath the ice. Whatever the precise mechanism, both interpretations point to the same unsettling conclusion. Something beneath that frozen shell was, at some point in Pluto's relatively recent history, warm enough to force liquid material all the way to the surface. That leftover internal warmth feeds directly into one of the most debated ideas surrounding Pluto today, the possibility of a genuine liquid ocean buried roughly 100 miles beneath the surface, kept from freezing solid by the slow decay of radioactive elements in Pluto's rocky core. The evidence isn't a photograph, it's a pattern. Cracks and ridges across the surface line up exactly the way you'd expect if a hidden layer of liquid water were shifting slowly underneath the crust, and that same pale, heart-shaped plane sits directly above what appears to be a positive gravity anomaly, a concentration of something denser than the surrounding ice hiding just beneath it. If that ocean is real, it means buried oceans, already strongly suspected on Jupiter's moon Europa and Saturn's moon Enceladus, might be a far more common feature of icy worlds throughout the outer solar system than anyone assumed, rather than a rare exception limited to the handful of moons closest to giant planets. It would also mean the most basic conditions life requires might exist on a world with no meaningful connection to sunlight or a nearby star at all. Right now, there's no way to confirm any of it directly. There's no funded mission planning to send another spacecraft back to Pluto, no lander, no orbiter, largely because a return trip would eat up the better part of a decade, and outer solar system exploration rarely wins out against cheaper, faster missions closer to home. For now, Webb remains the only tool we have, quietly checking back on Pluto every few months whenever it swings back into view, adding one more data point each time, and almost always making the picture stranger than it was before. Pluto sits inside the Kuiper Belt, a ring of icy debris beyond Neptune's orbit believed to hold hundreds of thousands of objects wider than 60 miles, alongside an estimated trillion or more comets. An area of space hundreds of times larger than the asteroid belt most people picture when they think of a field of space rocks. Only one spacecraft has ever ventured deep enough into that region to closely photograph anything there, and even that mission only managed close flybys of 2 objects out of the hundreds of thousands believed to exist. If Pluto is genuinely cooling its own sky, slowly bleeding its atmosphere onto a companion moon, and possibly hiding a liquid ocean beneath solid ice, there's no real reason to assume it's the only object out there doing something like this. It's simply the one close enough and bright enough for our instruments to study in this kind of detail. Everything else scattered across that same vast, mostly unexplored region is still waiting for someone to look closely enough to find out what it's been hiding too.